Hello, ladies and gentlemen. It's test review time. We got sections 2.3 to 2.5. This is all about polynomials. So you need to be able to graph them and describe end behavior and tell me what's going to happen on the x-axis and find zeros and use long division and synthetic division. It's all in here. We're trying to make it so that it's kind of all one big problem. But first, let's do some of these just graphing. So for these problems, this first one is already in a factored form. So since it's already factored, you got to pay attention to the degree. You can't just look at it. You need to add up the exponents. So you have x to the first, and then this would be an x squared if you FOIL it out, and then another x to the first. So this thing is actually even, so the degree is 4. And it's got a negative leading coefficient. You can see there's a minus sign in the front right there. So since it's negative and even, I know it's going to look kind of like an M. It's going to open down. Now, when we're trying to actually plot it, we need to find the zeros. So you got to set each factor equal to 0. And the one that people forget the most often is this guy right here. X equals 0 is a 0 because if you plug 0 in, 0 times all this other stuff will be 0. Anytime you have a GCF that has an X in it, then that is now a 0, X equals 0. So here we have a GCF that was X, or a factor that was X. That means we could just set the factor equal to 0, and that's a 0. The other two are going to be at positive 2 and at negative 1. So let's put these on the graph. Let's see. We got 0 and negative 1, and positive 2. Now, we also have to pay attention to the x-axis behavior. So I know it's going to end down here, but what happens along the x-axis? So these are called multiplicities. If you have an even degree multiplicity, it will bounce off the x-axis. If it is odd, like these are both odd, it's going to pass through. So we're going to work left to right. When we get to negative 1, that's this factor. That's an odd degree multiplicity because it's 1 right there. So we're going to pass through. Then we're going to turn around. And when we get to 0, that's also an odd degree multiplicity. It's x to the first. So 1 is odd, so we pass through again. And then we go back for the third 0. This is an even degree multiplicity. 2 is even, which means when we hit that x-intercept, it's going to bounce off. So you have a bounce at 2 and then a pass through at negative 1 and 0. Now we're going to describe our end behavior, and we're going to use limit notation here. So for limit notation, we're going to say the limit of the function, which we're saying p of x in this, and we have to have 2 of them. So as you go to the right, it goes down, and then the same thing, the limit of the function as x goes to negative infinity is also negative infinity. This is saying you go right and down. As x gets bigger, y gets smaller. X goes to the right, y goes down. Here, x goes to the left, y also gets smaller. So you can see we're using limit notation to describe the end behavior. It's pretty much the same as the y stuff we've done in the past. Now the second one is not already factored, so that's the first thing I'm going to do is factor it. And I hate having a minus sign in the front, so I'm going to factor out at least the minus, but also they're all even. So I'm going to factor out a negative 2, and now I have, I can't do an x, so I'll have positive x cubed, and then plus 2x squared, and then minus 4x, and then minus 8. It's important you pay attention to the signs there. Since we factored out a negative, all those signs end up flipping. Now, I think I could factor this by grouping, so let's try it. The GCF of the first two terms would be x squared, and I'd have x plus 2. Bring down the minus. Their GCF is 4, and that would be x plus 2 again, because negative 4 times positive 2 is negative 8. So my factors are x squared minus 4. I have the negative 2 out front, and then I have x plus 2. But this guy, that's dots, so I can keep going. That's x minus 2, x plus 2. If you factor this, you get x minus 2, x plus 2. There's another x plus 2 there, so what I'm going to do is say, okay, it's squared. Because I could write it out twice, but what you need to remember is that when you're doing these graphs, the multiplicities matter, so I'm going to write it as a 2, and then I remember, oh, it's going to bounce off a negative 2. All right. So my x-intercepts are at positive and negative 2, so on my x-axis I'll put little tick marks there. Positive and negative 2 are my zeros. And since this is negative odd, as I read left to right, it's decreasing, so it's going to look something like this. So I'm starting up here. When I get to negative 2, I have an even degree multiplicity. 2 is even. So it's going to bounce off, and then it's going to turn around, and then it's going to get to this guy. And since this is an odd degree multiplicity, that's 1, it passes through. So here's my graph. Yeah, that looks pretty good. I think I'm good. If I want to like label the y-intercept, 0, 16. It's in standard form, so you can just look at it right there. But let's see end behavior. The limit of p of x equals, as you go to the right, as x goes to infinity, this is negative infinity, goes down. And then the limit of p of x as x goes to negative infinity. As you go to the left, y goes up, so this is positive infinity. All right, next two are already in factored form, so we can probably go a little quicker. This is degree 10, 6 plus 3 plus 1, so degree 10, it's a positive, so it's going to look like a W. And I'm going to have zeros at this factor equals 0, and then 5, 1, 2, 3, 4, 5, and then negative 4, 1, 2, 3, 4. So there's my x-axis. Are any of these going to bounce? This is odd, so it'll be a pass-through. This is odd, so it'll be a pass-through. But I'll bounce off of negative 4 because it's an even degree. So it starts up here. It's going to bounce off of negative 4. It's going to turn around, pass through, and it's going to turn it again and pass through. I don't know or care where these local mins and maxes are. That's not the point. We're looking at the x-axis, and we're looking at the end behavior. Okay. So in limit notation, this is the limit of p of x. Both of them equal infinity as you go to the right, and the limit of p of x is infinity as you go to the left as well. So they're both infinity. One more. First thing, degree is 1 plus 2 plus 2, so 5, degree 5. That means it's positive odd, so it's going to look something like this. My zeros are at 0. This is 7 halves, so we'll say that's 3.5. That's about right here. And then negative 5. 1, 2, 3, 4, 5 right there. So I got my x-intercepts. I'm going to bounce off of 3/5, and I'm going to bounce off of negative 5. So I'm going to bounce off of negative... Ooh, let's try it again. Bounce off of negative 5, pass through, and then bounce off of 3/5. I missed. I can do better. Bounce, pass through, bounce. That's pretty good. Okay. So kind of a funky looking graph. I like that. But you have 2 bounces and 1 pass through. And we'll say our end behavior, the limit of p of x as x goes to, as you go to the right, y goes up. The limit of p of x as x goes to negative infinity. As you go left, it goes down. Okay? Polynomial long division. All right, so polynomial long division, we're going to say our divisor, x squared. I'm going to put a placeholder in there because it helps stuff line up better. You can see that there's not an x to the first, so I'll put a 0x in there. And this guy has all of its terms. So x to the 4th plus 4x cubed plus 4x squared plus 12x plus 3. This might take a little bit of space, so I might need to do this. All right, so the game is figure out what you multiply x squared by to get x to the 4th. That would be x squared. And now I'm going to distribute the x squared into the divisor. So I have to distribute. That means x squared times x squared is x to the 4th. X squared times 0x, so I'll just put 0x cubed. And then 3 times x squared is 3x squared. Now when you do long division, the next step is flip your signs, and you have to flip all of these signs. I like to use a different colored pen or pencil, or in my computer, I can just use yellow. And now what will happen every time is those should cancel. If your first terms don't cancel, you're kind of wasting your time. You're not doing long division. Now I'm going to subtract 4x minus 0. Well, that's 4x cubed. And 4x squared minus 3x squared is 1x squared. And I'll bring down the 12x because I'm working with a trinomial. Do it again. What do you got to multiply x squared by to get 4x cubed? That would be 4x. Now I distribute. So that's 4x cubed plus 0x squared plus 12x. And now I flip my signs. Minus, minus, minus. Those will always cancel. So what do I got now? X squared minus 0x squared is x squared. Those cancel too. All right, that's kind of cool. Now I'm just going to put a 0x in there and bring down the 3. Because those canceled out. Again, I want 3 terms because this is a trinomial. But you might notice something's going on here. So what are you going to multiply x squared by to get x squared? 1. Distribute the 1. You get x squared plus 0x plus 3. And when you flip your signs, cancel. 0 minus 0 is 0. And 3 minus 3 is also 0. So that means the remainder is 0. Oh, that's not a 0. 0. But I'll say up here, the remainder is 0. Now I'm going to write my answer as, oh wait, no, it says, is it a factor? So the question is it a factor? And I should be able to explain to you, yes, it is a factor. I'm going to write it as quotient. The quotient is x squared plus 4x plus 1. And the divisor is x squared plus 3. And there is no remainder. So if there is no remainder, this is the factored form. This was a quartic, degree 4, but I've now factored it into the product of two quadratics. If I FOIL this out, I will get the dividend, and that's going to happen in the next question. We're going to check it. But we have time. Let's do it. We'll do x squared times x squared, that's x to the 4th, plus 3x squared, plus 4x cubed, plus 12x, plus x squared, plus 3. So this is x to the 4th, 4x cubed, 3x squared, and one more x squared make 4x squared. And then a 12x plus 3. So did I do it right? X to the 4th, 4, yeah. Yes, I did. Look, is it a factor? Yep, and here's the factored form. So I know it's a factor, and the main thing I'm asking for is show me the remainder is 0. If you can show me the remainder is 0, then you can say it divides evenly. That's how we've said this before. It divides evenly. It goes into it without any remainder. So this is the factored form. Yes, it's a factor. Let's try another one. Long division. So I've got x plus 5 is my divisor, x plus 5, and then I have 3x cubed plus 14x squared minus 8x minus 50 as my dividend. So what am I going to multiply x by to get 3x cubed? 3x squared. Now I'll distribute that. 3x cubed plus 15x squared. Flip the sign, minus, minus, cancel. 14 minus 15 is negative 1x squared. Bring down the 8x. Do it again. X times what gives you negative x squared? Negative x. Distribute a negative x. Negative x times x is negative x squared. And negative x times 5 is negative 5x, which will then get flipped. Plus, plus, cancel. And you get negative 8 plus 5, which is negative 3x minus 15. And then we do it one more time. X times negative 3 gives you negative 3x minus 15. And if you'll notice, cancel or change the signs, cancel, and those also cancel. So again, in this problem, we get, 0 as the remainder. So we'll say remainder 0. Now, it says write your answer is quotient times divisor plus remainder. So the quotient is 3x squared minus x minus 3. The divisor is x plus 5, and there is no remainder, so I don't need to worry about it. So there's my answer. Now, the next thing it tells me to do is algebraically verify my solution. That's what I did up here. If you have the quotient times the divisor plus the remainder, you should get the dividend. So we're going to FOIL it out. 3x squared, it's not my FOIL literal. 3x squared times x is 3x cubed. 3x squared times 5 is 15x squared. Negative x times x is negative x squared. Negative x times 5 is, negative 5x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. So I got 3x cubed plus 14x squared minus 8x minus 15. Is that good? Is that what it's supposed to be? 3x cubed plus 14x squared. Hey, look at that. I did it right. Boom. I got the dividend. So how do I know that I did it right? Because the quotient times the divisor is the dividend. There is no remainder, so I don't have to worry about it. But the quotient times the divisor plus the remainder is the dividend. That's how you know you did it right. All right, so now the last thing we're going to do is, and these are all the same kind of problem, we're going to analyze these polynomials. So we're going to have to find x-intercepts. That can be kind of annoying. We might have to use a quadratic formula. That can be kind of annoying. These problems can be quite lengthy, so you're going to have to just have a strategy here. Like, you got to have a game plan. What am I going to do first? Well, first thing it says, describe the end behavior. It's positive and it's odd, so I'll say the limit of f of x as x goes to infinity. As you go to the right, it's going to go up. The limit of f of x as x goes to negative infinity. As you go left, it's going to go down. So left down, right up. Y-intercept is at 0, 6. 6 is the number on the end there. And now we're going to find zeros. So first thing, try and factor by grouping. Sometimes you get lucky. X squared, x plus 1 minus 2, x minus, no, that's not, doesn't work. Can't factor by grouping. Bummer. So how are we going to find rational zeros? We're going to have to list out potential rational zeros by listing factors. The factor of the leading coefficient 1 is just 1, so that's nice. But the factors of 6 are 1, 2, 3, and 6. That means I can try plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, or plus or minus 6 over 1. And I need to do that until I find a 0, because once I can get 1, 0, I'll have a quadratic. So let's just guess. Let's try, I don't know, let's try, well, first let me set up my synthetic division. We're just going to use synthetic division and find one that works. So my coefficients are 1, 1, negative 4, and 6. And I might need more of these. Get out of here. There we go. Okay, get back here. Boom, there you go. All right, so find all zeros. Let's try positive 3. I'm feeling lucky. Bring down the 1. 3 times 1 is 3. Add. 3 times 4 is 12. Add. 3 times 8 is 24. That's 30. Nope. Okay. Bummer. All right, let's try something else. How about negative 3? And you could be here all day. You might just not have good luck and have to try a bunch of them. So 1, negative 3 times 1 is negative 3. Add, negative 2. Multiply, 6. Add, 2. Multiply. Hey, got one. All right. Okay, so we have a 0. Now, if negative 3 is a 0, then that means you just factored out x plus 3. So we just factored out x plus 3, and here's our quotient. It was degree 3, so now we're degree 2. This will be 1x squared minus 2x plus 2. Now I have it factored with a quadratic term, but I have to solve the quadratic, and you can do this however you want. If it's factorable, do that. Does anything multiply to 2 and add to negative 2? No. So, what do quadratic formula? Quadratic formula. So the opposite, well, first I'll do discriminant. So b squared minus 4ac. That's 4 minus 8. So this is negative 4. Now the quadratic formula will be the opposite of b. So 2 plus or minus the square root of. The discriminant is negative 4 over 2a. 2 times 1 is 2. So it's going to be 2 plus or minus. The square root of 4 is 2, but since it's negative, it's 2i. And then when you distribute the 1/2, you get 1 plus or minus 1i. So my x-intercepts are at negative 3. The only one is at negative 3, but my other two zeros are complex. They're at 1 plus or minus i. Those don't show up on the graph. Complex zeros don't show up on the graph. So let's put a dot at negative 3, and we'll sketch it. It's positive odd. It's a odd degree multiplicity, so it's going to do this, and then probably turn around or something like that. And then my y-intercept is at 0, 6, because 6 is on the end there. 0, 6. Okay. All right, so there's one down. Let's do a few more. Here you got a cubic. Well, first we'll describe the end behavior. Again, positive odd. So the limit of f of x, as you go to the right, it's going to go up. It's going to look like this. The limit of f of x as x goes to negative infinity. As you go to the left, it's going to go down, so negative infinity. Y-intercept is at 0, negative 10. Now let's find some zeros. So you got to be careful. There's a missing degree here. There's not an x squared. So when you do synthetic division, you might have some that are, you have to have placeholder 0 is what I'm getting at. So we'll have 2, 0, negative 3, negative 10. If you forget that placeholder 0 for 0x squared, you will never get a problem right. You cannot do synthetic division without all of the terms. You have to be very careful. All right. A couple of these. Let's see how we do here. What do we want to try? Well, we got 1 and 2 as our leading coefficients, and 1, 2, 5, and 10. So it could be 1 over 1, 2 over 1, 5 over 1, or 10 over 1. Or it could be with the denominator being 2. So 1/2, 2 halves, 2 over 2 is 1 whole. I'm not going to write that. 5 halves, or 10 over 2 is 5, which, again, I already have that one as well. So those are repeats. I'm not going to list it twice. Let's just start going. Let's try 1, 2, 2, 2, 2, 1, 1, negative 9. Nope. All right, let's try. that was negative, negative. That should be negative 11. I was like, something doesn't look right. Okay. Negative 3 plus positive 2 is negative 1. It doesn't matter. It's not 0 anyway. Let's try 2. 2, multiply, 4, add, multiply, 8, add, 5. Ooh, 10. Yep, got it. Okay. So now I have 2x squared plus 4x plus 5. And since 2 is a 0, x minus 2 is a factor. Let's see. I got a quadratic. That's good. I got one of my zeros. That's good. Now I need to figure out how I'm going to solve this thing. Does anything multiply to 10 and add to 4? No. So we're going to do quadratic formula. B squared minus 4ac. 16 minus 8 times 5 is 40. 16 minus 40 is negative 24. Which I'm going to have to simplify that. So let's make a factor tree for 24. 2 and 6, 2 and 3. That'll be 2 radical 6. The square root of 24 is 2 radical 6. Here's my factor tree. So the opposite of b, negative 4, plus or minus 2 radical 6. Oh, but it's negative, so it'll be 2i radical 6, because it's negative 24. Over 2a, 2 times 2 is 4. Now when you distribute the 1/4, negative 4 divided by 4 is negative 1. And 2 divided by 4 is 1/2. So it'll be I radical 6, and we'll just put it all over 2. So there's 2 of my zeros, and the third one is at positive 2. So there we go. Again, these are complex, so they don't show up on the x-axis, but this guy's not. So we'll put a dot at 2. 1, 2. And we'll try and sketch it. We know it's going to be positive odd, so it probably looks something like, I can hit that better. How about like that? Probably something like that. This might be more of a turnaround. Y-intercept is at 0, negative 10, and this is at 2, 0. All right, 2 down. Now, this would be a good time for you guys to hit pause, do the last 2 on the back on your own, and then watch me do them. Because if I just sit here and talk at you, you're not getting nearly as much out of this as if you actually work through the problems. So hit pause, try it, then watch me do it. I've done a couple, so you should be able to do that now. Okay? Here we go. First thing, end behavior, limit of f of x as you go to the right will be, this is positive even, so it's going to be w. So they're both going up. Infinity, limit of f of x as x goes to negative infinity. As you go to the left, also infinity. Y-intercept, wait a minute, 0, so 0, 0. All right. Now we got to find zeros. Okay. Work smarter, not harder. If you see that you have factoring you can do, do it. Factor out the x's. Everybody's got an x. 2x cubed minus 5x squared plus 4x minus 1. Now I have a cubic. I'm looking for factors of 1 and 2. This is 2. So if I list my factors and try and find some positive or some rational zeros here, it could be 1 over 1 or 1 over 2, and that's it. There's only 4 possible rational zeros I have to try. So let's start with 1, and we'll see how it goes. 2, negative 5, positive 4, negative 1. Bring down 2, multiply, add, multiply. First try again. All right. So now I have 2x squared minus 3x plus 1, and my other factor is x minus 1. If 1 is a 0, x minus 1 is a factor. I think this is factorable. So once you get to the quadratic, you're like, oh, do I have to do quadratic formula again? Maybe. Does anything multiply to 2 and add to negative 3? Yeah, I can split the middle. 2x squared minus 2x minus 1x. If I split the middle, 2x. X minus 1 minus 1, x minus 1. I get 2x minus 1 and x minus 1. And then there's another x minus 1, which means this will be x minus 1. Instead of writing it x minus 1 again, you want to write it squared. That way you remember, oh, it's multiplicity. I'm going to bounce off the x-axis at positive 1. So where are my zeros? Positive 1/2 and positive 1, which is a multiplicity degree 2. So let's put them on the x-axis. 1, 2. 1/2, positive 1. Oh, and 0. Don't forget about 0. So because I forgot 0. We'll put that on there. X equals 0. There we go. because x was a factor. Remember, x was a factor, so don't forget about 0. So I have 3 x-intercepts. It's positive, it's even, and I'm going to bounce off of which one? 1. Positive 1, because it's a degree 2 factor. So I'm going to bounce off of 1. So we'll start up here. We will pass through, and then pass through, and then instead of passing through one more time, we're going to bounce off at 1. Which got a little bit messed up there, but it's pretty good effort anyway. So one more. Again, you should try it first before I do it. This is also positive even, so the limit of the function f of x as x goes to infinity will be infinity. The limit of the function as x goes to negative infinity will be positive infinity. Y-intercept is at 13. Find all zeros. Okay, let's see what we should try. So to do that, I think I'm recording. I don't know what just happened there. We're going to have 1 and 5 as our factors and 1 and 13. So it could be 1 over 1 or 13 over 1 or 1 over 5 and 13 over 5. I'm definitely going to pick, I'm going to start at 1 again. I've had luck here. Whoever makes these problems is being pretty nice. What a nice guy, right? 5, 8, negative 18, negative 8, 13. So let's see if 1 works. Bring down the 5, multiply, add, multiply, add, multiply, add. First try again? Amazing. So now I have 5x cubed plus 13x squared minus 5x minus 13. It was a quartic. Now it's a cubic. And if 1's a 0, x minus 1's a factor. Now I got something here that I could do the same thing. I could keep trying rational zeros. But why would I do that when I can maybe factor by grouping? And I think I can. If I do x squared, I'll have 5x plus 13 minus 1. Look at that. 5x plus 13. So my factors are x squared minus 1, 5x plus 13, and then I have another x minus 1. But that's dots. X plus 1, x minus 1, and then there's another x minus 1, so I'll square it, and then 5x plus 13. Whoa, what happened there? 5x plus 13. Okay, so where are my zeros? My zeros are at negative 1, my zeros are at positive 1, and negative 13 over 5. But remember, this is a double count, so 1, 2, 3, 4, that's all of them. But we're going to bounce off of the x-axis there. So at negative 2.6, that's 13/5. And positive and negative 1. So we'll put 1 here, we'll put 1 at negative 1, and we'll put 1 at positive 1. So let's see. Positive even, it's going to be a W, but I'm going to bounce off of 1. So it's going to be a pass through, I'll do it in red. Pass through, bounce off at 1, and then go up. I'm going to do it again. I can do better. Pass through, that's better. Bounce. And I'll put this is at 0, 13. Okay, we did it. That's everything you need to be able to do. The main thing, I think, if you can do the last 4 problems here, all these analyzed problems, that really puts everything together. So I would strongly recommend that you put in the work on those. Go through your notes. You have a couple extra practice problems you could be doing. You have 3 My Math Labs that you should be doing. You have a practice test on Schoology you can do. I'm going to be on Zoom here in the morning if you guys need to get some help or you have any questions, shoot me an email. But our test is coming up, so hit the books, like and subscribe, and good luck.